Hello everyone, Mr. Baxter here, and today we're going to be learning about passive and active transport. Now within our organelle unit and our macromolecule unit, we learned about the cell membrane. Now the cell membrane is special because it surrounds the cell, allows stability of the cell, making sure things don't come in and out, and helps to protect it as well. We also know that it is a bilayer, meaning that there are two layers with it. And on the inside, the heads are very much hydrophilic. They are not afraid of the water on the inside and out. But the tails here are hydrophobic. They are afraid of the water. So because of that, it allows for certain things to pass through. Because it allows for certain things to pass through, we call the cell membrane selectively permeable. Now, rocks are normally porous or permeable because they allow for space for liquids to go through. But the cell membrane is not, so we call that a selectively permeable cell membrane. Only certain things are allowed in unless energy is acted upon it. Now here's a version of the cell membrane you guys will have on your page. The two biggest ones to know is this protein here and the cholesterol. The protein is a channel to allow things to pass through, and your cholesterol helps to keep the stability up within the cell membrane. Now, we're going to start out here with diffusion. As you watch the next slide, pay attention to how the molecules are crossing the membrane. Now, I want you guys to note that we have a high concentration here, meaning that there's a lot of particles up at the top, and a low concentration, so there's a low amount of oxygen within that area. Now notice what's happening as the CO or the O2 is passing through the nonpolar membrane. Again, because it's nonpolar, it'll be repelling the water. And you might have noticed that the water or the oxygen pretty much moved in any direction that it wanted to. Because whenever small nonpolar molecules move from a high concentration to a low concentration, we call that diffusion. Now a couple things to note with that. Molecules are still moving from high to low concentrations due to random collisions. This is not because they want to go from the high to low concentration because it's crowded, but because it's very crowded and it just gets pushed out of that area. They are not forced or pushed or pumped through the membrane. They don't want to leave. To get to the low concentration. Instead, they're just pushed out. And there's no energy required. The ATP energy is not required in diffusion. It just happens randomly, and they go from a less crowded or more crowded to less crowded area. Now, we get into the terminology of facilitated diffusion. If you're being facilitated, you're being helped from one location to another, like a ramp for someone in a wheelchair. I want you guys again to notice what's happening. We have more Na up top than we do at the bottom. So the top area is going to be a high concentration area. The low concentration will be at the bottom. Now, because of the movement of the Na molecules that you see here, eventually some of them will just move around and eventually will be pushed into this protein molecule that we have here as it goes from a high concentration to a low concentration. Now, something to note with that, if this area here got crowded as well, it would be more likely for the Na molecules to go back up the protein channel. Notice as well the sugar molecules that we have, high concentration here, low concentration here. Eventually, while they aren't moving around here, the sugar molecules will pass through the cell membrane to a lower concentration. To repeat myself, molecules are still moving from high to low concentration due to random collisions, and they are not forced nor pushed nor pumped through the protein, and there's no energy required for this, so there's no ATP. But just like the fusion, except the molecules cannot pass through the nonpolar part of the membrane, so they have a specific protein channel that they can pass through. Now, there's also something called osmosis as well, as osmosis is the movement of water. Within osmosis, again, there's a higher concentration down here than there is at the top, and while this here is a polar molecule, the water being nonpolar can still move through the membrane because of something called an aquaporous type of solution. In my days since watching the EOC I've never seen this term here show up, but the important part to know about about osmosis is how the water molecules are moving freely throughout the membrane from one side to another. Osmosis is the fusion of water to where water molecules are still moving from a high concentration to low concentration through random collisions. Again, they are not being pushed, and there's no energy required within the ATP, but the water molecules are still able to move through the nonpolar region. No energy required. In a moment, you guys will learn about hypertonic, isotonic, and hypotonic, about how the cells can start to shrivel or grow because of what we talked about. Now, the last part that we have is active transport. And again, I want you guys to notice what's happening here. We have more molecules here in the high concentration of Ca2+ than the low concentration. But because of ATP, or energy, these molecules are being pushed into an area of higher concentration. Active just means that energy is being used. We are actively moving. Within this, molecules are moving in active transport from an area of low concentration to an area of high concentration. In this case, they are pumped through a protein channel. While it still is random, it's being pushed through to that location. And in order to push something like packing a suitcase too full and putting too much stuff into it, it requires a lot of energy for that to happen. Of course, we have ATP again that is required. To summarize, we have an active transport that requires energy as molecules move from a low to high concentration. And later on, you'll learn about endocytosis and exocytosis, to where molecules are either exiting the cell or entering the cell. Passive transport, no energy is required. Molecules move from a high to low concentration, and that includes simple diffusion, osmosis, and facilitated diffusion. Let me know if you have any other questions. Otherwise, you guys have a good rest of the day. Bye.